I'll let you look at number 5 for a minute, then I'll move it down to 6. Let's look at any question number 5. We're pretty good on 5. You're going to reflect about the what axis? Move it what? Left 5 and then what? So if it's on the x-axis, you don't move it. I'm going to move it left 5. 1, 2, 3, 4, 5, down 1. It's 1 away here. It's going to be 1 here. 1, 2, 3, 4, 5, down 1. It's 4 away. Come down here. 1, 2, 3, 4, 5, down 1. That's how we would do number 5, and so forth. Okay, let's look at number 6.
I don't know what happens if I want 3, 4, and 9 went missing. Am I going to get that from the homework check?
Probably not, because I'm not going to have a graph for you. Your homework check, because I won't have a graph on there, because it's going to take you too long to draw a graph. All right, number 6. Thank y'all for doing your homework. Good job.
Hey, Mr.
Yes.
Does Jeff State tell you how to arrange your desk? Because both of my dual enrollment classes have these little pods.
Mm-hmm.
Okay.
This is the pod I got started last year. I used to have it in rows of 3 across, and then I just like this better. All right. Only thing Jeff State does is gives me the syllabus. It says teacher. All right. Number 6. Are there any question number 6? Let's just say what we would do. Reflect about the, move it, and then, very good. All right. Now let's do 10 and 12 together just to make sure. Number 10. What's our parent function there, Matthew? On number 10, what's our parent function, buddy? Square root. So I'm going to graph that. Square root of 4 is 2. So there's my parent function. All right. So let's say this, what we're doing out loud. What's the first thing we do, Phone? What will we do here? Hold on just a second. Phone, go ahead. Stretch by a factor of 3 vertically. That affects the what coordinates? X or Y? Then we're going to move it what, guys? Left 1, then what? Okay, so this is 0, 0. If I take and multiply my y coordinate by 3, I'm still at 0, 0, aren't I? I'm going to move it left 1, down 2. 1, 1, I'm going to multiply my y coordinate by 3. I'm actually at 1, 3. Move it right 1, down 2. 4, 2, I'm going to multiply that y coordinate by 3. I'm at 4, 6. Move it right, left 1, down 2. Did y'all look something like that? Okay. All right, number 12. We're going to stretch or shrink here.
Can I see number 10?
Yep. Right here, what we're going to do, stretch or shrink? Shrink by a factor of, move right 3 and then what? Down 2. Okay, if the number's inside next to x, it affects the what coordinates? x and it's opposite of what you think. If you see a whole number, it would have been shrink if you saw a fraction stretch. We didn't have one like that, but do you remember how to do that? Okay. All right. So number 12, my parent function is the what, guys? Cubic. So I'm going to graph 0, 0, 1, 1, negative 1, negative 1. All right. So I'm going to multiply my y coordinates by 1/2. I do that 0, 0, still going to be 0, 0. Move it right 3. 1, 2, 3, down 2. Okay. I have 1, negative 1. That's going to be negative 1, negative 1/2. Move right 3. 1, 2, 3, down 1. Down 2, I'm sorry. One, 2, 3, down 1, 2. Okay, 1, 1 times it, that'd be 1, 1/2. Move it over right 3. 1, 2, 3, down 2, 1, 2. Now I can do the table to make sure if you like the table better. Multiply the y coordinate by 1/2. I'm going to add 3 to x because that's moving it to the right. Alright, so add 3. That's going to be 2, 3, 4. And then I'm going to add a negative 2 to that. That's going to be negative 2.5, negative 2, and negative 1.5. And those are the coordinates I would graph. Are there any questions? Okay, before we start a new learning target, let's review what we've learned so far in this unit. Are we still good at determining if a function is continuous at a given point? Okay, if you plug in and you get your answer, it's continuous. If you don't, if you run into okay, if it's a piecewise, what type of discontinuity is it automatic? Jump. If you cannot cancel it out, it's what? And what is occurring there? Asymptote. If you can cancel it out, what type of discontinuity? Removable. Very good. Do we still remember how to determine the AROC of a function? Okay? The formula would be the same. X sub 2 minus X sub 1 on the bottom, and right above it, F of X sub 2 minus F of X sub 1. Are we good on that? Remember also when we review this tomorrow, a position time graph of how to read one, of where it was like moving away, or is it staying constant, those type of things. Are we still good with that? Okay. Then we've been talking about transformation for 3 days. I'm ready to move on to something else. So today our learning target is this. I can graph piecewise functions. And we're going to work on that for the next 2 days. I can graph piecewise functions. And we're going to be on page 59. Page 59. Now you got 6 of these for homework, which I'm going to talk to you about quickly. It's page 57. This is going to be your homework 6 problems. And you say, Mr. Chester, what is all this? Haven't we learned how to already... You're graphing them here, but haven't we already evaluated piecewise? So that's just reviewing you to make sure you still know how to evaluate piecewise, okay? So if I said f of negative 2, which one would I plug it into? The top piece or the bottom piece? The top, because that's less than 0, isn't it? Okay? So that's just a review. So I just wanted you to see that you're going to have some review of evaluate, but you're going to graph them on that graph. All right. So we're on at page 59, and I wrote it on this big graph paper so you could see what we're doing here. So we're not doing every one of these because you don't need 12 examples, but we're going to start with number 2, okay? So let's look at number 2. Alright. Y'all remember doing these last year a little bit? Alright. I'm going to do it the long way first, and then I'm going to show you a shortcut, okay? Because I want you to understand why it is what it is, okay? So on this first one here, f of x is just another way of writing y, isn't it? So we're going to actually graph y equals -1. Y equals -1. And I'm having to do it in pencil, guys, because I'm going to have to erase something in a minute. But that's y equals -1. Let me zoom it in. And then the other one we're graphing is y equals -x plus 2. Alright. This piecewise has two pieces to it. And something's going on at what number here? 0. I call that the restriction point, okay? I don't know if it was a scientific name. I just made it restriction point. That's the restriction point. Something's going on there. So I go ahead and find that number on my graph at x equals 0. Something's going on right there. Alright. Let's graph this. Y equals -1. Y equals -1 is what type of line? Horizontal. So it would just be a flat line, horizontal like that. Now the other one is -x plus 2. That's in slope-intercept form, isn't it? So I go to, what would I graph first, slope or y-intercept? Y-intercept, because a slope is a ratio. That's not a point, is it? So you're going to graph the 2 first. What's that negative slope say to do? I'm going to go down 1 over 1, aren't I? Alright, so at my restriction point 0 right here, you're getting off one piece and getting on the other one. You're getting off one train, getting on the other train. Restriction point right here is like the train depot. It says for this one, you stay on this piece, the -1 piece, for all x values less than 0. So if I look here, where's my x values less than 0? That. So you want to keep that part because that is over there with the x values less than 0. Don't those correspond with that part of the function? Okay, so that means I'm going to erase this part over here. Now, so I'm going to erase this part right here. Now, would that be an open or closed dot there, guys? Open. Go back to my restriction point. Go up to where I hit that function. I hit it there, don't I? Y'all see that? Would it be an open or closed dot there? Closed. Now it wants that piece to be for all x values greater than. Where's my x values greater than 0? Is it that way or this way? You see all these x values that's greater than 0? So I'm going to keep that part. Do you see that? And that would be my answer there. Y'all remember doing that last year? Now, what I still want you to do is tell me domain and range, though. We got to get our domain and range practice in. Now, I'm going to show you the shortcut in a minute. And then I'm going to let you decide what you'd rather do. You know what? We're just going to do it that way and just be done with it. How about that? because I don't want to show you too many ways and you're all confused and we'll be doing. No, I will, because you're intelligent. Never mind. I will show it to you. Domain. Okay. What's your domain? If I start from the left, am I hitting the graph?
Yes.
Do I have to worry about this as that's right there? No. My domain is what? RL numbers. Start from the bottom. Remember, that arrow keeps going, don't it? So my range, even though it's open there, is something closed over here. Yeah, so my range is what? 2, bracket. Okay, I'm going to show you the shortcut on this one so you can see where. The shortcut means you don't have to draw and erase. You just draw the parts you need and don't have to erase. Okay? The shortcut basically says this. At your restriction point, you got 0. You take 0 and plug in. Like here. If I take 0 and plug in, well, there's nowhere to plug it in, is it? So you know that it's going to be, you go to -1, it's a horizontal line. And you look at it. You put an open dot and you look, okay, instead of drawing the whole line, it just wants the x values less than 0. So you see the x values less than 0 is over here. So you just drew that part right there. Here, what you do when it's like a normal line, you plug 0 in. -0 is just 0, isn't it? 0 plus 2 is 2. You go to 0 and go up to that, plot that point. You just evaluated the function at 0. That's 0, 2, isn't it? That will be a closed dot, and then use the slope. Okay, you want it for x values greater than 0. So you use your slope, down 1 over 1, down 1 over 1, and just graph the parts you need.
If you were to plug it in, it would also be the same.
Mm-hmm. Which way do y'all like better?
I'd write 10, so I like the second one.
Okay, just make sure you get the right answer, okay? Okay, we'll do this. But if you have to do the first way, do the first way, okay? Alright, number 3. Where's my restriction point? Where's catching my eye? What number's catching my eye? So I'm going to put a little mark there to let myself know that something going on at -1. Alright, instead of drawing the whole line, I need to find my point at -1. I plug -1 in here. What's -1 plus 3? You know what? I'm going to even do this. Let's make sure we know what we're doing here. I'm going to write my lines like this. I'm going to plug my -1 in. And I get 2. So I need to go plot what point? -1 and 2. So -1, 2. At that point, would that be open or closed? Closed. Now, we're looking at, we're going to use the slope from this one to help construct the rest of the line. What's your slope here? 1. Okay. Normal slope, okay, our slope is +1. We would go up 1 over 1, wouldn't we? Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. But is that the direction we want to go for that piece? Because it's for x values what? So we need to be going this way, don't we? So we're going to go backwards, okay? Ready? Down 1, over 1. Down 1, over 1. Down 1, over 1. Just put you a nice, healthy bit of points. You talking about coloring them? No, that's inequalities. It's just the open or closed dot is what needs to deal with. How many were taught this way, the shortcut way last year, the restriction point? Okay. How many was taught the other way? Okay, there was either 2 ways. It was either the other way or restriction. I'm going to ask that question one more time. Okay, that's going to be the third multiple choice I give. Okay, that's great. Okay, good answer. How many were taught the shortcut way? Raise your hand. Keep them up. How many were taught the graph both lines and erase? How many don't remember? Okay. Well, then this is a whole new ballgame. Okay, here we go. Now, we're going to evaluate this function at this point to see where our starting point is going to be. So we have y equals negative 2. So I'm going to go to negative 1, negative 2. Negative 1, negative 2. Would it be open or closed dot? Open. Now remember, this is for x values greater than negative 1. So this is going to be for these x values over here, okay? Now we're going to use our slope, which is what? 2. Let's try it. Up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. Would that give me the area I need to go? Yes. If not, I would have go backwards, wouldn't I? So up 2 over 1. Up 2 over 1. Up 2 over 1. And that is my graph. However, if you like to draw both of them and erase them like I did at the beginning, you are more than welcome to do that, okay? First time, yes. And see, that's what I did in pre-AP Algebra 2 for you to understand it. And then when you get to here, you can understand how you can just go plug it in and start from that point instead of doing the whole thing. Okay, what's my domain? All real numbers. Even though there's that cancels it out, don't it? So your domain's all real numbers. My range, start from the bottom. This arrow keeps going, don't it? So what's my range? So let's review. I just want to make sure we're okay so far. Things to look at. First thing I do when I look at these problems, guys, is look at my restriction point. I look at my restriction point and I highlight it right there on my graph. Okay? I evaluate both of these at the restriction point. I evaluate them both at the restriction point. That lets me know where I'm going to start with my point for that particular piece of function. I plugged a negative 1 in and I got 2, so I'm graphing negative 1, 2. Then I looked at my function. I looked at my slope. Okay, normally it goes up 1 over 1, up 1 over 1, up 1 over 1, so forth. But since this is for x values less than negative 1, I need the values this way. So I went backwards to get my piece for that function. Then I evaluated the second one at negative 1. Plugged negative 1 in, got negative 2. So I graphed negative 1, negative 2. Okay, try my slope. Up 2 over 1, up 2. Is it giving me the direction I need to go? Yes, because these x values are greater than negative 1. There's an open dot here because it's a greater than. It's a closed dot because it's greater than or equal to. Are there any questions so far? Okay. Let's look at number 5. On number 5 here, what's our restriction point? 1. I'm going to highlight it, okay? I'm going to highlight it at 1. I take 1, I plug it in. Does it work? Can I plug 1 in? No, so what will be my point? 1 what? 3. So I go up 1 to 3, close dot, because it's less than or equal to. It says for x values less than or equal to 1, so will I go to the left or to the right?
Left.
Okay. Then I got the graph y equals x squared. I plug 1 in, I get 1. So now I'm going to 1, 1. Would that be an open or closed dot? Open. And what's the point? We already know the point. We don't do slope on quadratics. What's the next point after 1, 1? It's 2 what? 1, 2, 3, 4. Yep. And then we're just okay. Now my question is this: x values greater than 1 would be over here, wouldn't it? That's why I'm going this way and not this way, because these x values are greater than 1, so I'm drawing it this way. Does that make sense?
You're only drawing half.
Yes. I did not draw the rest of this parabola because I wanted the x values greater than 1. My x values greater than 1. These x values are what's hitting this function over here, guys. That's where these x values exist, is the piece I'm drawing there. And that would be my graph. your domain from the left, what's my domain? Because this cancels that out, doesn't it? What's my range? Parentheses 1, 2. Very good. Parker, how you doing over? Good. All right. Yes.
Is it alright if on these I draw like a dotted line in a different color?
No, it's not. You doing that at your restriction point?
Yes.
Okay. All right, number 6. What's my restriction point? 1. It's not always going to be 1, guys. It just happens to be yes in these problems. 1. Okay, I'm going to plug 1 in my first one. Y equals x squared, y equals 1 squared, y equals 1. So I'm going to go to 1, 1. Would that be an open or closed dot at 1, 1? Closed. Now, guys, it wants for the x values less than or equal to 1. So would I go to the left or to the right? Left. So I'm going to be going this way, this way. So what's else on my parabola? I got 1, 1. What else? 0, 0, negative 1, 1, and what? So I'm going to draw it going like this. Next, y equals 2x plus 1. Evaluated at 1, I get 2, 3. 1, 3. Plug 1 in. So I'm going to go to 1, up to 3. Open or closed? Open. Now I'm going to try my slope first, which is what? 2. Up 2 over 1. Is it going the direction I need it to go? There's my graph. My domain, remember the arrows keep going, so yeah, now does this cancel that out? Yes, so I don't have to stop for that. My range would be what? Very good. How about this break right here? But isn't over here defined for that little area on the y-axis? So that's why that's good. We're going to do one more, and then tomorrow we're going to keep practicing this. Is it catching on better second year in a row? To me, you're mature over the sophomore, junior year, and by the time you're juniors or seniors, this makes more sense. How you feeling, Derek?
Good.
Good. All right, now here we got more than one restriction point, don't we? We got 3 pieces. So what's our first restriction point? This is number 10. Number 10. Probably our last one for the day. So what's our first restriction point? And then what's our other one? 2, okay? I think Mr. Moore called them fence posts last year if you had Mr. Moore. Okay. Alright, let's look at this. Look at this first one. If I take negative 4 and plug it in, is there anywhere for that to be plugged in at? So what point would I plot? Negative 4 what? 1, 2, 3. Open or closed? Okay, and it's for the values less than or equal to negative 4, so I would go to the left or to the right? There's my first piece. I'm going to check that off. I did that one. Now you said, Mr. Hester, what does this mean? What do you think this means here? For all values between what 2 numbers?
Negative 4 and 2.
So would you have to plug both of those into for the restriction point? Yes. You got to plug negative 4 in to see where that point's at, and then plug 2 in to see where that point's at, okay? So, if I take negative 4, if I take negative 4 and plug in for x, that's negative 4, isn't it? So would that be an open or closed dot here? Open there. The other one's open as well. Plug 2 in, I get 2, 2. Oh, about to mess up. So I plugged negative 4 in, got negative 4, negative 4. I plug 2 in, got 2, 2. Now I'm going to draw my line. Now I did, no, I should have used my slope. What's my slope here, guys? 1. Up 1 over 1, up 1 over 1, up 1 over 1. You see how I used my slope there? I should have done that. I got too happy. But we should know that's the identity function, shouldn't we? That's why I need to draw it to the origin. Alright, now I'm going to plug 2 in. Be careful here, because what's understood from the x? It'll be negative 2 plus 6, which is 4. So I'm going to graph 2, 4. Open or closed? Closed. Now, what is my slope for this one? Negative 1. So let's see if it works here. If I go down 1 over 1, 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 is that taking care of the values greater than or equal to 2? So I would do that. If not, I would have went backwards with my slope. But that does work. Isn't it just pretty? Those graphs are so pretty to me. Now let's do domain and range. Domain, start from the left. Do I hit something?
Yes.
These cancel each other out, so you don't have to stop. Does these cancel each other out?
Yes.
Does it keep going? Yes, domain's all real numbers. Now I'm going to ask you a question. If I asked you for f of 2 here, which value would you give me? 2 or 4? 4, because it's a closed dot. That means it's defined. Okay, let's start the range. This is tricky. It is at what? 1, 2, 3, 4. Negative 4, but would I put a parentheses or bracket? Huh? Okay. The error is going. What? Oh! You're right. You're right. That error keeps going. Good job. Negative infinity to what, guys? 4. Very good, bracket. Good job, guys. How do y'all feel about day 1? Just day 1 now. You got to give me another day on it if you feel it. If you feel 60%, I need a thumbs up. Like this. Like this. To the chest. To the chest. Okay. We're going to get to 100 tomorrow. Alright. The ones for homework is real easy. Like, I didn't give you any challenging ones. I just want to make sure you get the skill down, okay? So just evaluate them. Do the domain range and graph, domain range, and evaluate, okay? Yes, better. Good class day, guys.